All right. Hopefully everyone can hear me, and I will let me switch my monitor here. Bear with me one more second. All right. So, thanks for joining. My name is Frank Vigne. I am a data scientist at Wintellect. Some of you may know me through my blog, Frank's World TV, franksworld.com, YouTube channel, Frank's World TV, or my data science podcast, Data Driven, which is available on all the popular platforms. You can also find me on Twitter at tableteer. That is a name that I chose many moons ago when I was doing tablet PC development. You may also recognize my name because I have a regular column on in MSDN on artificial intelligence and data science. And just want to give a quick shout out to the folks listening. Yeah, we don't have Muzak. Maybe next time we will. So let's talk about Wintellect briefly. Wintellect's core services are consulting, instructor-led training, and on-demand training. We do custom software application development and architecture, and naturally now data science and analytics. We also have instructor-led training. It's the #1 training vendor for over 14 years, having trained more than 50,000 Microsoft developers. We also have an on-demand training program offering, including quite a few courses now on data science. In fact, Mark Tabadillo just recently released an entire series on using Spark on HD Insight. I also have a similar themed course there on basically data science for developers and what it takes to get started. So clearly, if you're on this call, this is something that's near and dear to your heart, and you might want to check it out. Wintellect has been an industry influencer. We quite literally wrote the book. Actually, more than that. We wrote over 30 books that are the de facto reference standards for Windows and .NET, and I foresee that going forward into the data science world. I myself have written a book. It was a Silverlight book, but perhaps I will write a Power BI book or data science book in the near future. Here are some highlights about the company. It's a Gold Azure partner. In 2016, it won the Gold Partner of the Year for the United States. And that was announced at the World Partner Conference. Our CEO is the Regional Director for Atlanta. We also have a DevOps competency, and we have multiple ALM Rangers on staff. We also are a Xamarin Premier Consulting Partner with multiple Xamarin certified engineers, and chosen to teach the 2-day Xamarin University Precon at Evolve 2016. We also have certifications in software competency, Visual Studio Integration Partner, Azure Circle Partner, ALM Inner Circle Partner, MVP of the Year, and much, much more. But today's talk is about data. Very often you hear this term used, and it was more data has been created in 2017 than in the previous 5,000 years of human history. Now, what does that exactly mean, right? I mean, that's kind of one of those sound bites you hear on the news, and it doesn't really make a lot of sense. But basically, data is increasing in volume, velocity, variety, veracity, viability, and value, right? You've heard the 3 V's. Some people now say it's the 4 V's or the 5 V's. But basically, by 2020, which is just, think about this, just 2 years away, 1.7 megs of information will be created every second for every human being on the planet. That's a lot of data. Also, data can now be processed at a faster rate than ever before. It can also be created at a faster rate than ever before. Data also has a variety problem. No longer is data in nice little tables and packages. 75% of data, roughly, is unstructured. And along with that kind of unstructuredness is the accuracy and consistency of that data. How accurate is the data? Just because you get a value from a sensor doesn't mean it's accurate. How do you detect outliers? Value, spotting trends and anticipating customer behavior. Can you take all this data and essentially monetize it? So in terms of what exactly is creating all this data? Well, any number of things, and this is just plenty of infographics on the internet. I'm sure this one is from a month ago, so it's probably woefully outdated. But if you look at, in 1 minute, and every minute of the day, 2.4 million pieces of content are shared on Facebook. Skype users connect for 23,000 hours in a minute. So, plus there's any number of things. So what does this mean? What does this new ability to capture data, to generate data, user content created data, what does that mean exactly? Well, you might have heard this phrase, because this was on the cover of The Economist not that long ago, that data is the new oil. And that seems like a very, well, I don't want to say controversial, but it does seem to me, be a bit hyperbole. I certainly thought that, but then I, took a closer look and, well, maybe it's not that crazy. Oil is a latent asset. In other words, just because oil is discovered, say, under your house, doesn't mean it really has any intrinsic, necessarily value. It has to be refined from its raw state. As we see, oil is a vast source of wealth for nations and corporations and individuals. And it changed its widespread availability and production changed our agriculture, it changed industry, it changed the world. So what does that mean then? How does data apply to this? Well, data is also a latent asset. I have data, you have data, my dog has data, but what does it mean? Like, it does no, every moment I'm clicking on the website, I'm generating data, I'm creating digital exhaust. But what exactly does that mean? It has no value unless it's extracted in mind. So if you look at companies like Google and Facebook, they are generating an enormous amount of wealth, basically just on anticipating your behavior and your patterns so that they can serve up ads that are most relevant to you. And this is changing agriculture, this is changing industry, this is changing the world. So then the question then becomes, how do you get in on this? How do you make the most of your data? So basically what data can do for your business is essentially 5 categories. One is you discover trends and opportunities. You can figure out what's going to be the next hot thing. You can anticipate market behavior because, as it turns out, humans are actually creatures of habit. And if you could collect enough data and figure out one person's tastes, you can anticipate another person's tastes. You see this most famously on Netflix and Amazon. So when you buy something on Amazon, you are immediately recommended similar products. Now, I heard 2 different statistics on this, is that accounts for 50% of their business to 75% of their business. It doesn't really matter exactly what that number is, even if it's a third, right? They kind of upsell you on extra things that you might be interested in based on previous customer patterns. That's a significant boost in income, and probably a big part of why Amazon is dominating the retail space these days. Same with Netflix, right? How do you discover new content? How do you discover new contents to watch? Well, you do that through basically recommendation systems. Secondly, this lets you experiment. You could theorize, you could create models, come up with hypotheses where you could basically say, well, what if we lower the price on this product? Would people buy $1? I don't know. How is that going to affect sales? Right? And you could run these kind of experimental theoretical models in completely a virtual space, and really, no effort or anything like that. Thirdly, and this is one of the things that probably gets the news, is the intelligence. You can make smart apps. So part and parcel of this is something like computer vision, right? I'll pull up Amazon again. One of the things that if you have the Amazon app, it'll actually use computer vision to search for something similar to what you're looking for, which is it's quite fascinating if you think about it. Because not that long ago, computer vision was, well, the stuff of science fiction. So the idea that you can automate the process of, determining whether or not, is there a, in the popular TV show, Silicon Valley, this is a picture of a hot dog or not a picture of a hot dog. Right now we joke about that, but that's actually something that's very real because you can scan at bulk. You can scan for offensive content, for hate speech content, or racy content, or you can rate that. Now, is it going to be perfect? No. But the point here is that this is something that was usually the purview of human beings that would make those judgments. Now, we're handing that off to machines. And that opens up a lot of doors, right? You talk about changing the world on the scale that oil did. Think driverless cars, right? That's all computer vision. Well, not all computer vision, but a big chunk of that is computer vision. Now, I touched on this before, where you can predict, you can anticipate market shifts, but you can adjust your business to be a data-driven business because you can be where the opportunities are. You can you can find customers that are most at risk of leaving your service and offer them features to retain them, right? This is something that is, customer loss was always kind of just assumed as being part of the cost of business, now, or it was not really easy to determine. Now it is. If you set up the right data collection mechanisms and use the right algorithms, you can be ahead of that. You can predict what's going to happen next. Sometimes even before the customer really has crystallized the idea in their head. And finally, what good is all of this if you can't communicate this, right? What good is having all this data if you can't convince or influence top decision makers in your company or just in general, right? So part of this is also visualizing the data, coming up with ways to share any kind of insights that you've gleaned. Now, I mentioned that this is changing industries, so we can kind of take a look at this. Here's an excellent guy to follow on Twitter, Mike Quindazzi. He always posts some great content in this space. Basically, this is something that people call the fourth industrial revolution, how this is changing everything. And when I say everything, I mean everything. Everything from medicine to agriculture to advertising, healthcare, transportation, mentioned Amazon, that's retail, energy. This is changing everything. And how does that happen? Well, at the core of it, you have the infrastructure, right? You have the cloud, IoT, mobile, big data systems. And then built on top of that, you have AI applications, deep learning, cognitive systems, intelligent automations, computer vision, etc. And those applications, 5 or 6 things could be mixed and matched in so many ways. It's really changing the nature of our society. In fact, if you go back 100 years, the automobile was just getting traction as being a mainstream device. Uh-oh, did the sound stop for everyone? Okay, so, no, good. So this is changing things. So if you go back 100 years, the car had just really come out and become mainstream. The world was a different place, right? People walked most of the places they go. If you go most places, everything was within walking distance. Suburbia could not exist without the automobile, right? So many things changed that were not directly related to this. So we don't know how this is going to end. And that's what's exciting about this. A little scary too. So I discovered that you can discover market trends, customer behavior. You can flag fraudulent transactions, right? And you can do this in, well, near real time. I was recently at a resort in Maryland, and I guess somebody swiped a copy of my card, and my card was disabled. And they were like, "Well, did you buy this? Were you in Baltimore? Were you in Honolulu? And were you in Eastern Europe?" And I was like, "No, I never left the DC area." And so that's how they were able to tell that if certain things kind of pop up that are squirrely. Now, a human can do this, right? That's what we're good at. But the resources to hire enough people to catch this stuff in close to real time is very expensive. To do it in real time is just not possible for the human brain to do. And that's what's exciting about this. So you can experiment on new strategies with new marketing campaigns, promotional offers, customer loyalty programs, right? These are all things that you could do. With intelligence, you can make your application smarter, right? You can augment existing user interfaces. If you look at something like Alexa, where it is I actually have an Alexa in the room I'm in, and she just lit up. You could play music, start music, turn on lights, do any number of things with just your voice. Now, most people on the call may be like, well, what kind of a big deal is that? Well, one, think about the accessibility for people who have motor issues or don't have arms, right? Using a mouse or using a computer is not exactly the most intuitive thing for them. So this opens up the application of more technology to more people. It really opens up some new possibilities. So you can also predict. One of the more famous commercials you see here in the States is the one where a gentleman walks up to the security guard with, dressed as a repairman, and says, "I'm here to fix the elevator." Security guard positively looks back and says, "The elevator's not broken." And then, the repairman looks and winks and says, "Not yet." And then we cut to a commercial for Watson, where you're basically determining that, if you have sensors on equipment, you can then monitor the slight variations and find a pattern that precedes an equipment breakdown. Now, if you're running a factory line or a machinery line, that's a big deal. If you can keep the assembly line going, by anticipating breakdowns, you save a lot of money, right? We already talked about customer behavior and the market opportunity. Seeing market opportunity before it manifests itself in reality. That's pretty amazing. You can also predict supply chain challenges too. This time of year, you get certain snow in this part of the area, and then how does that affect you getting supplies there or getting things from there, right? And then last but certainly not least is the ability to communicate insights, to do data exploration without really writing any code, just playing around with it, finding patterns. So I've spoken about how great this is, and well, what does this look like? What does it look like for someone who's a software engineer? What is this? How do you implement this? Well, here's really the analytics pipeline, right? You ingest information, you basically get the information, you store it, you transform it, and then you run analysis of it, and you deploy or you make a decision based on the analysis that you made. So, and really what's really made this possible, because none of this stuff is necessarily new, right? We've had databases for the better part of 60 years. We've had computers for the better part of, pushing 70 years now, right? What has really made this possible is the cloud, right? The ability to scale up to such a degree and then scale down right away. That's really the power here. So how has this really made this happen? Well, cloud computing has enabled cheap compute and effectively limitless storage. Because before this, when you had big data, right, the definition of big data at one point was if you're worried about how you're going to store it, all this terabytes and terabytes of data, then how do your mind cannot roam free into the world of the possible, right? The art of the possible when you're worried about kind of the basic stuff. Cloud has really taken that away. Now, obviously, there's budgetary concerns, but the cost of renting terabytes of data for weeks or months is cheaper than buying equipment that can do that. So what exactly is data science, right? Well, it's the hot new thing, right? Harvard runs around calling it the sexiest job of the 21st century. Well, it's not really all that new. In fact, a lot of this looks a lot like something called predictive statistics, which have been around for, well, quite some time. But wait, there's more to the hype train here, right? There's AI, there's ML, there's RL, right? And math. There's an awful lot of math. Now, most people, when they hear math, they kind of have this repulsive thing here, and very few people will recall taking statistics classes in college with joy and nostalgia. But I'm here to tell you that if you make a statistician of yourself, a lot of this becomes easy, right? And that really gets into, well, who is a data scientist, right? So there's an old joke in data science circles, right? Who's a data scientist? Well, it's a statistician who can sling code, right? Or a coder who understands statistics. Now, in truth, there's really no clear answer here. In fact, a lot of folks who are kind of leading the industry have PhDs in math, science, and statistics. But what we're finding is that the vision of kind of a mad data scientist is somewhat false. Because reality is that it's going to take a team to take on some of these biggest problems. You're going to need data architects, software engineers, subject matter experts, right? So essentially, data science and data analytics is a convergence of disciplines. It's a, if you want to think of it like a mashup, it's a mashup of math and statistics, software engineering, and data communication. Now, you'll see in this Venn diagram, to be a quote-unquote data scientist, you didn't see the air quotes, you have to have a combination of all three. Well, I don't think that's necessarily the case, because a combination of all three is essentially a non-existent or very rare person indeed. So why is it called science, right? Because you hear the term data science, right? Why is it not just called data analytics? Although it is. Basically, here's the key component here. You pose a theory, you make a prediction, and you may run an experiment and you observe the results. That's the scientific method. And that's essentially what happens here. Go back to, if I were to make an offer to this type of customer, I predict that they'll do this. Well, then you run an experiment. And then you observe the results, right? And then you tweak your theory, and then you continue, right? So you're continually evolving. The world's largest online retailer, I've been told, they're able to manipulate the prices of items millions of times a day. And they test, obviously in an automated fashion, how it's received, right? And they do this in nanoseconds, and it's something that no human being could reasonably do. But so they're able to gather data on customer behavior and customer willingness to purchase something based on price at a rate faster than any brick and mortar store could possibly do, right? Because it's entirely automated. And they can gather that data, and they know more about what you're going to buy next, probably than you do. I say that somewhat facetiously, but certainly you heard the story of a few years ago. There was a father who contacted a Target because his daughter was suddenly receiving basically coupons for diapers and baby formula and things like that. And he voiced his frustration rather strongly at the store manager. Turns out his daughter actually was pregnant, and he issued an apology a few days later. So this is being done today. This isn't a revolution that's coming in the next few years. This has already happened. In fact, the Target story is already a couple of years old now. So that's why it's called science. All right, so one of the things that really frustrated me when I made the switch from being a software engineer to a data scientist a couple of years ago was you go to YouTube, right? And like, I'm going to learn this, right? Because you can learn pretty much anything on YouTube. And then they start using words that just make no sense, right? They start talking about, this algorithm, and we ran this type of, mechanism on it. We used Bayesian classification, or, it just made no sense. Well, it's a new field, and there's new jargon, and there's literally limitless three-letter acronyms. So I'm here. I'm going to help dispel some of that. So next time you listen to a podcast, or you watch a YouTube video about this, it's not going to sound like Charlie Brown's Parents, right? So where they basically make absolutely no sense. They start talking, and then you understand what they're saying, and then what. Okay. So this is kind of a taxonomy. I don't know why my slides just hung up. Let's see. All right. This is a rough kind of categorization of how this is. You have the field of artificial intelligence, and what really powers artificial intelligence is massive amounts of data. That's effectively That's effectively how it works. So you have kind of the initial kind of children here, machine learning, natural language processing, speech, expert systems, robotics, and computer vision. Now, some people will argue with me over the details of where certain things fall. That's not important right now. The important thing is you understand how things fall into context, right? So deep learning, predictive analytics is part of machine learning, right? The idea that you can present an algorithm with enough data that the algorithm itself can kind of figure out what's going on, right? Natural language processing, you know, if you feed an algorithm all the history of books written on a particular topic, how do you know exactly what's coming out of it, right? How do you summarize that data? How do you parse through that? How do you find classification and clustering it, right? How many, if I'm talking about dogs, right? How many of that talks about their genetic distinction from the wolf versus, basic training, right? If I pulled in all the information on dogs on the internet, right? Are there breed-specific things? Are there natural questions that kind of pop up? There's also speech-to-text. Expert systems is the idea that you could turn a fact into a chatbot. In fact, that's one of the things. That is closely tied, in my mind, with natural language processing, because if I type in, how do I tie a tie, right? How does that algorithm parse that into a logical and actionable activity, right? Or if I tell my Amazon Echo that I want to dim the lights, what happens behind the scenes? Robotics is another field here. Planning and optimization, right? The old traveling salesman problem. Vision, right? Image recognition, machine vision. How can you make a self-driving car without the ability to see obstacles or read signs even? So that's kind of part of it. But all in all, the key difference here, and this is the part that really, really trips up software engineers, is we are so used to writing algorithms that solve problems, right? I want to do a bubble sort, right? I write an algorithm to do a bubble sort. The difference here, and the key difference, and if you remember nothing else today from today's talk, is that in data science and AI, algorithms are not written to solve a problem. They are written in such a way that they figure out problems, they figure out solutions to themselves. That is a complete inversion to the software development paradigm we've known for the last 7 decades. This is the part that really blows your mind, right? Because in your career as a data scientist, the chances are you're not going to write an algorithm to do something. What you will do is assemble existing algorithms to solve a problem. Whether you do that in ML Studio, whether you do that in scikit-learn, OpenCV, or any other number of libraries, you're consuming somebody else's tools, and you're basically assembling them, right? So, well, what about machine learning? How exactly does that break down? Well, here's a great example. There's 3 types of machine learning. There's supervised learning, unsupervised learning, and the newest kind of kid on the block, reinforcement learning. Although we'll find out that just like a lot of things in this field, it's not really that new. All right, so for example, given a picture set of cats and dogs, now in supervised learning, you tell the computer which photos contain cats and which photos contain dogs, right? And then somehow the algorithm will go and determine what visual cues there are between the difference of the two. Unsupervised learning is you give the computer pictures of cats and pictures of dogs, and it'll, if you give it enough data, it'll kind of cluster it out, and then say like, well, it'll categorize them into 2 clusters. The computer, the algorithm won't necessarily know that one's a lump of pictures of cats or pictures of dogs, but it will separate them eventually at some point into 2 parts. Now, reinforcement learning is probably the most exciting, and it is the most that manages to mimic natural intelligence, right? Where the idea is you reward the computer for right answers and you punish the computer for wrong answers. Now, how do you reward a computer and punish a computer? I don't know, no RAM upgrade for you, but just work with me here. So let's talk cake, right? Unsupervised learning is kind of the cake, right? You need a large amount of samples. Supervised learning is you need less samples. Now, the real cherry on top here is with the least amount of samples. So think about if you want to teach a kid the difference between cats and dogs, it's not that hard to do, right? Actually, a lot of goes on behind the scenes, but basically after 3, 4 exposures, a kid could figure out what's a cat and what's a dog. So here's an interesting discussion about that, actually. So I'm going to do a real-time test on a neural network right now. In fact, 175 neural networks all at once without writing a single line of code. And the answer is, well, I'm testing your neural networks, right? And we'll talk about the importance of decision boundaries and what distance from decision boundary means. But just keep that in mind. Now, I'm going to test all your neural networks, right? The brains that you have that have learned to distinguish between cats and dogs. All right? Are you ready? All right. Now, tell me, is this a cat or is this a dog? I'll wait till everyone can see it because I think we're at 97%. 99. All right. So hopefully by now you've answered that this is a dog, and in fact, it is. All right. Ready? Ready? Next one. What animal is that? Is that a cat or a dog? Right? Very good. It's a cat. Now, you're 2 for 2. Don't get too confident just yet. Here comes the third animal. Is this a cat or is this a dog? Now, if you're like most people, you probably jump to a conclusion right away, and then you kind of had this, well, wait a minute. That's clearly a dog. No, wait. You could probably feel yourself waffling, right? Is it a dog? Is it a cat? Right? And what this is trying to prove is that natural neural networks, natural intelligence, can also be fooled. And basically, it's a good exercise or thought experiment in determining how do you know the difference between a cat and a dog? If you see just the face of the animal, how do you tell, right? Well, it's got scruffy long hair, it's got pointy ears, it's of a certain size. I mean, clearly this is not a Great Dane. It's a small creature, so maybe it's a dog. And then you think, well, those eyes are kind of very cat-like, aren't they? Well, it turns out from the image I got this from on the website, it says it was a cat. So that's what we call the ground truth. But I mean, equally, you could say it's a cat, you could say it's a dog. It's not, it's wrong, obviously, because clearly it's one or the other. It can't be both. But what makes it so hard to determine? And basically, the notion here is decision boundaries. So if I can pull out my little laser pointer here, speaking of cats, right? If I have a sample, if I chart it, and it ends up being over here, then clearly, it's clearly in the blue camp, right? So let's say blue is dog, right, and red is cat. Now, if I have something that's closer to here, and you see how that line of demarcation or that decision boundary, aka the decision of, in my mind, I've decided it's a cat or a dog or whatever that is going to be, clearly the closer I am to that, the more ambiguous things get, right? People talk about shades of gray, right? Not the book, but kind of like, black or white. Well, along that boundary line, it's kind of gray, right? You don't necessarily know. Could it be one or could it be the other? And so in other words, this distance from the decision boundary matters. And this is important, particularly as we get in more and more automated systems that determine public health or public safety. Bad data in means bad decisions out, right? And garbage in, garbage out is not a new concept in computer engineering, right? That's been around since before I was born. All right, so basically in this case, we have here is it's a problem of linear regression, right? And basically it all comes down to the slope of a line. We can figure out, this is called regression because what you're doing is you're trying to figure out, you're back engineering the formula to create that decision boundary, right? And this all goes back to actually to middle school math, if you could believe that. Y equals mx plus b. I don't know if you remember that, or I don't know if you remember. I personally disliked math in middle school. It wasn't until I was in high school that I actually found out I liked it. So that's the idea, is that you figure out the slope of a line or the formula, so that way given a new input of x, you can figure out the y, right? You can figure out the relation between the two. Now here's where it gets really, really interesting. All right, now, excuse me. How would you draw a straight line through this? And in this case, you want to draw a straight line in such a way that you leave yellow balls on one side of the line and red balls on the other side. How do you do that? Well, it's a kind of a trick question. You really can't, right? But what about now? And this is I'm going to play an animated GIF here, so if it doesn't work, forgive me. But it worked pretty good in testing, right? So how about now? What if I wanted to separate them two with a nice distance there? Now, hopefully what you're seeing is I basically added an extra dimension. So instead of having 2 dimensions of change, let's see, can I stop the animated GIF? So in other words, let me go back. I see a question here. Right, so somebody did say that you have to eliminate outliers that impose a crappy demarcation line. Yes, Baker, you do win the prize for yes, you are absolutely right there. But the point here I'm trying to demonstrate is that this isn't real in the sense of if you add an extra dimension here. So what we're seeing now is a 2-dimensional representation of data, right? And the coloring and the X and the Y are kind of arbitrary. But if I add an extra dimension by basically saying the red balls are higher than the yellow balls, I can then add a nice straight line, or technically speaking, a hyperplane, which basically means that the more dimensions you add, the more accurate you can be. And if that doesn't hurt your brain a little bit, you're not paying attention. So if you're confused, that's good. You've been listening. So this is an algorithm known as a support vector machine. And essentially, it adds another dimension, or actually in one case on one product I was on, I had 412 dimensions to compare data sets on. And the advantage that machines have over humans is their ability to think beyond 3 or 4 dimensions, right? Because beyond, we have 3 spatial dimensions and kind of plus time. And if you use some clever visualization techniques, you could probably visualize maybe up to 7 or 8 dimensions. Beyond that, it starts getting a little bit hard for our human brains to kind of get our heads around that. So that makes sense. If it doesn't make sense, I do have a demo I can show you. Let's see if I can switch my screen now. I'm going to stop sharing my screen and then go to my actual screen. All right, so I'm going to pull over this browser window here. And this is a great website. It's playground.tensorflow.org. TensorFlow is a open source artificial intelligence and machine learning framework by Google, I believe. And basically, this is to demonstrate how you can play around with a neural network. To get into neural networks, but the idea here is that you can run this simulation here, and you'll see how it's classifying that in real time. And you'll see eventually it does get it, right? So it draws the decision boundary, here represented as white. So it's managed to neatly classify those structures there, right? So let's give it something a little easier. But what's really cool about this is you can experiment this, you can add extra lines of demarcation, you can change kind of how things work. But the key thing here is, and notice how much more faster it got to this because it's a simpler pattern for it to figure out. But basically the first level that goes in, you feed it in that, you feed it in this, and then these neurons here then make distinguishing the discrimination based on that kind of demarcation, and then eventually it comes out very neatly. Really recommend that. And then here's another interesting one, and you'll get to see my mug, and that would be teachable machine with google.com. This is going to use my, I'm going to skip the tutorial, and it's going to fire up my webcam. And I don't know if you get to see me. Hi. So basically what I'm going to do is I'm going to train the neural network right here, right in front of everyone. And I'm going to click on train green. And I'll look around. All right. So now you see me with that. Now you'll see that right now it's reporting that what it's seeing is green because there's only one thing for it to do. So I'm going to put my hand out like this, and I'll train this. Now what I want to show you is, and the cat GIF, I mean, this just changes what it says. So if green is found, then it grows that. I'm going to train it now, and I'm going to put my hand there. And we'll see now, as it switches to the picture of the dog, it's basically indicating that it's detected condition purple, right? And right, like that. If I do my other hand, you see it has to think about it because it's not sure, because some of those cues it was trained on were different. Now, if I were to train this, that I had both these hands, right? So I'll add that to my training material, although I am right-handed, so that's going to be fun. I'll add this here. So now, let's see what happens now. I put my hand this way, I put my hand that way, and you'll see, well, it's not quite as confident, but what happens if I put two hands there? It's like, okay, I give up his hands, right? So we can actually now add a third state, so where I'm holding up, here I just got this, holding up this box. So now I'll train it, so condition orange will be, it's looking at this box, right? So we'll see now, should go back to green because it's just me, my lovely face. I put my hand up on my face, we get condition purple. This box appears anywhere in the frame. You'll see that. Now it's interesting, you can play around with this, and you can kind of see at what point does the neural network consider this box is not in frame, right? So you'll see confidence starts to dip a little bit, and it goes away, and then it kind of comes back. What's actually fun, if you look at the video that's down here, there's actually people that make funny faces and do all kinds of crazy things, and it's fun to watch that because you get a feel for how the computer is working, right? How does the computer make its decisions, right? It doesn't always find what you think it's finding. In fact, sometimes it finds a way to differentiate itself in ways that you didn't really intend to, and that leads to some interesting situations in the real world. All right, so I am now ready to take questions. Any questions at this point? So the question I see here is, does the decision boundary change with more knowledge? I am thinking of someone who is a cat expert and not being confused by example. Exactly. So you notice in an example where it was confused about my hand or whatever, more data in ultimately leads to a better model, right? That's why you go to school for X number of years, right? Someone who has a PhD in, say, if you're going to be operated, right, you want the guy or gal that went to school for 10 years, not the one who just attended a lecture or watched a YouTube video last night, right? It's kind of the thing. You want the person who has all that additional training, and absolutely. So that's why with 30 samples you probably couldn't tell. If I threw in 3,000 samples, then the line would get a lot finer. All right, I'm trying to figure out a way I can expand the question window. There we go. All right. Amazon recently announced business services. What do you think of the future of Alexa in the business? What new security? It's funny. As I read that question, my Alexa just activated. Sorry. Yeah, Amazon currently. This is from Richard Ruth. I would say Amazon is having their big conference basically today and tomorrow in Vegas. I know for a fact from my previous kind of startup I worked on is that Amazon has a lot of stuff in store this year. Alexa is pretty much the leading home kind of assistant like that. It'll be interesting to see how it is. The security implications are enormous. There was an XKCD cartoon where, you know, he walks into a house and every time he says, "Hey Alexa, order me 2 tons of creamed corn." If he hears a response, he's like, "I'm leaving until you shut it off." Right? I mean, I don't know about that. But I mean, that's an interesting question. That's a great question with a very long answer. So thank you, Richard. But the short of it is, I think we're going to see these things prop up more and more and more in terms of automated kiosks, customer service bots. At some point, you're going to see, you already see kind of customer service kiosks where they ask you questions with a touchscreen. You know, at some point in the future, you'll be able to talk to something in order that. Dragon asks, would I recommend a book or class on this subject? Check out Wintellect's offerings on this. Obviously, they pay my salary, but I am particularly fond of the video I did. We also have a number of interesting videos. You can sign up and get a free trial. We get you information out to that. edX, edx.org. That's how Microsoft funnels their runs their complete certification program. Great resource. It's free. You only pay if you want to get the certificate. There's also datacamp.com. I have a podcast too you can listen to. Datadriven.tv is the website. Shameless plug. But you know, our audience is basically people who are developers or data engineers who want to know more about this data science thing, because it can be very intimidating. You look on YouTube. There's a lot of smart people on YouTube that don't really talk in language that normal people can understand. So I would say I would look at that. I would also look at this guy on YouTube called Suraj Raval, S-R-I-H-A, last name Raval, R-A-V-A-L. He does awesome classes. He does live streams where he says, you know what, I'm going to teach you how to build a neural network in TensorFlow in like 4 minutes. And he's like, it doesn't matter if you don't know what TensorFlow is, right? And you think, I'm thinking like, he's talented, but nobody can teach that in 4 minutes. He does it. He's amazing. I want to be him when I grow up. The recommendation part is in the market for a long time. I could see YouTube recommendations and Amazon's recommendations for 4 to 5 years. But what's the difference between what we have now there and why there's sudden hype around machine learning? That's a good question. I mean, you're right. Recommendation systems are not new. They've been around for a while. What is unique is they've gotten more accurate over the last 5, 6 years, particularly in the last couple of years. They've also become much more approachable, right? There's a William Gibson quote. William Gibson is a famous author, science fiction type guy, and he said, the future's already here. It's just not widely distributed yet. I mean, I had an Apple Newton. And if you don't know what Apple Newton is, that just makes me sad. But Apple Newton was a PDA that Apple came out with in the mid-90s. It had handwriting recognition on board. It wasn't really that good, but it had it. And now we look at handwriting recognition systems and or voice recognition systems and think, wow, that's amazing. They're not new. What is new is that they have an accuracy rate in the 90% now, whereas before, 70, 80%, which is good for some scenarios, but not others. So I think what you're really seeing, 2 things here, and with it's driving the hype. One, it's gotten better. The algorithms have gotten certainly not necessarily as good as human beings, but close enough. And 2, the approachability of this. You can train a neural network, as you saw in my browser. Now, was it a great neural network? Well, it's not going to. I'm not going to trust that algorithm to drive my car for me. But it did know within a short amount of time when a hand was in front of my face versus when a hand wasn't in front of my face. That's something that was possible if neural networks were created in I think the 70s, but it wasn't really necessarily approachable. We have better processing power now. We have access to cloud computing, which gives us effectively limitless compute, effectively limitless storage. Obviously, there is a limit, but you're just not going to reach it. It's the same way. Can you drink the ocean, right? Well, I guess you could, but it would take you several lifetimes to do, and this is not really going to happen. So effectively, it's limitless. Hopefully, I answered your question. Um, Kalash asks, and sorry if I mispronounced your name, the market, oh, I've already answered that. Any trends to follow over the next couple of years? Let's see if I read the whole question. How do I see the industry evolving in the next couple of years? Any trends to follow? I would say, and this is by Sarika, I would say the clearest thing is that what we consider data science now is going to be mainstream development within the next 5 to 10 years. And I know that sounds crazy, but let's go back in time 10 years ago, right? Mobile development was a niche thing on top of kind of general software engineering. Now, if you hire a developer, you look at job boards, what do they look for? They look for a full stack developer. Well, what does that mean exactly? Full stack means a lot of things to different people, but mobile is a big part of development. It's gone mainstream, so you can't really be a software engineer without at least knowing something about mobile. Go back 20 years ago, right? When I first started my career, right? You had enterprise developers and you had web developers, right? Two different animals. Over time, what becomes kind of niche and fringe becomes more and more mainstream. So the key here is that I think in the next 10 years, neural networks, artificial intelligence features, Alexa voice recognition, computer vision, it's all going to be just stuff we're going to drop into our apps. You're already seeing Microsoft build in things like R analytics tools, right? We didn't talk about the languages of data science, but there are two primary languages, Python and R. R is basically a domain-specific language for statisticians, statistical analysis software. You're going to see that more and more in the mainstream. So basically, if you're writing mobile apps now, you're having fun with React and Angular, that's great, that's awesome, but at some point in the future, this is going to be the new mainstream. I mean, look back 5-6 years ago. React wasn't really around. It wasn't really a thing. It might have existed, but it wasn't popular. Let's see. So Ashish Rawat asks, how much command on programming required for data scientists and job market? That's a tough one because the demand here is so high. You're going to have to at least know how to sling some Python at a minimum. The job market is looking very good. If you just do a search, it's a very sought-after thing. Henry asks, do you guys see more regulation of the industry for things like equality and social justice? I am thinking of an ML that predicts who can afford a loan, but it has some biases built in that punish minorities. It's funny you mentioned that. I used to work for Microsoft in public government affairs on K Street, basically working with elected officials and such, talking about exactly that. We have to be very cautious about how we go forward with this, and it's not just about affording a loan now. I mean, now you're talking about crime detection algorithms. That is, the ethics of that are just, I mean, another field that would be very good to get into is ethics of machine learning and artificial intelligence, because those problems aren't going away, and I could easily see that being regulated. Now, I'm not an elected official. I'm not on K Street anymore, but I mean that is definitely a thing. Because this isn't just a technology story anymore. This is affecting people's lives. This becomes an everything story. Will MATLAB survive in this space? Yeah, I mean, they'll survive. I think that they've already grown and adapted. I think they've already opened up some of their platform, and if you think back to 2-3 years ago, MATLAB has always been a niche thing because of what they did. Now this is becoming more and more mainstream. In fact, if they play it right, this could actually open up new markets for them. What is the basic requirement in terms of knowledge to become a data scientist? For me personally, when I was doing all the certifications, the moment I felt like I could understand these things is after I took the stats class at the online stats class from Columbia University. That one, it was a hard class. I'm not going to soft pedal it, but once I got over the statistics part of it, it started to make a lot more sense to me, right? If you looked at the formulas, you get math again. That was definitely, I think statistics is if you're already a programmer, and chances are if you've heard of Wintellect, you're already a software engineer, probably an accomplished one too. if you add statistics to your skill set and you study a little bit about this, you'll be really good at it, because that's really the shortage now is data engineers. So I once interviewed a lady on my podcast, and she relayed a story about how CEO of a Fortune 500 company came to her and said, I need PhDs in data science. That's basically what the requirement was. I need a top-notch data scientist, right? Long story short is that they brought in 50 at some point. Not one of them knew what ETL means, right? Extract, transfer, transform, and load, right? Not one of them knew. Now, they knew every nuance about data science itself and the mathematics and the formula, but they didn't know the core concepts of what we would call data engineering. That's an enormous opportunity space for software engineers to school up themselves on statistics and learn that side of the business. And once you learn that side of the business, I wouldn't say you snap your fingers, you'll be a data scientist overnight, but you can start playing in those games. You can start hanging out at those user groups and those meetups, right? You can start getting the lingo. Then you can start getting your legs in it, right? I mean, that's how I did it. Because 5 years ago, no one was really a data scientist. You had PhDs in math and PhDs in statistics that were doing work for Facebook and Google and Microsoft, but they weren't necessarily called data scientists. Any specific language knowledge preferred? Algorithms and data structures. I would say, and this is always a controversial thing, right? Back to the early days of .NET, right? Pick a language. Python is winning right now. R and Python are kind of the two languages of data science, but Python is the one that's really picked up steam in the last 12 to 18 months. Particularly when you see Google is basically embraced it whole hog. Microsoft is also embracing it whole hog. If you look at ML Workbench, it's basically a Python IDE. They don't call it that because when I tried to write that in my so here's another shameless plug. MSDN Magazine, the December issue, which should be out tomorrow, will have my first article on basically introducing ML Workbench, which is their new tool. And in an early draft of the article, I said, well, think of it like an IDE for Python, and the messaging wasn't right, but effectively that's what it is. Now it adds a lot of other interesting things that lets you experiment faster and kind of run codes. Dave Black, did my question come through? I do have a hard stop shortly after 3, and I am I'm new to this webinar software here, so bear with me. Okay, here's a question. I have a BS in math theory and I've worked as a software engineer for 24 years. What's the best way to get started in data science? Dust off those old statistics books, read them, Lynda.com has a lot of good courses on data science. Naturally, Wintellect does too. Oh, your wife made you dump those. Well, that's okay. You could probably get them on. There's a open source data science course. I'm trying to figure out what it's called. The name escapes me right now. There's also Wikipedia. I really like the edX classes. Those are really good. I'll see. I could send us all edX.org. Pluralsight, I don't know what their story is on data content is. They're obviously a competitor of ours. I love some of their courses. Wintellect has a bunch of stuff, and I would also say YouTube. YouTube is a great source. There's a lot of stuff. Twitter also has a lot of stuff. Hashtag data science, hashtag machine learning, hashtag AI. Franksworld.com, my blog. I always have something posted there. In fact, if I'm really heads down on a project, if the posts go down from 2 or 3 a day to 0 a day. Another source I like is there's a couple of great O'Reilly books on that. I currently am reading Hands-on Machine Learning with Scikit and TensorFlow. That's a really good book. I finished up. Actually, I'm looking at it right now. It's Data Science Essentials in Python. That's pretty good too. That does assume you kind of know what the algorithms are for. Actually, Dave, that might be good for you. Oh, please spell Raval's first name so I can find him in Google. How do I start typing? Oh, I click on this. and I believe that he's also, I think he's on Twitter. Suraj Raval. And tell him Frank sent you, because I'm trying to get him as a guest on my podcast. So tell him Frank sent you, because he's just awesome. Will Python.net ever take off? I don't know. Actually, I'm not exactly sure what Python is. You mean Iron Python? Or do you mean Python.net? Next question is there a direct relation between data science and NLP? Where to start studying NLP as data science? NLP stands for Natural Language Processing. That is depending on who you talk to, is a subset of this. Basically, it's the idea that you can take human language input and then have it parsable and understandable by a computer. The best way to start studying NLP is probably to start studying NLP. Most of the algorithms around NLP are variations on the theme of clustering and word count and word stemming. I would start there. How does data mining relate to all of this? That's a good question, Mustafa. The short answer is data mining is probably part of data science. Data science, we struggle this internally at Wintellect, right? Because, like, am I applied data? When we're working out what my title was, am I a data scientist? Am I applied data scientist? Some people feel that data scientist is a person with a PhD and works in the university, right? Or is a chief data officer at, like, Facebook or something. I think Richard Ruth just answered that question really awesomely. It's the E in ETL, extract. Yeah, I mean, basically data mining is another word. Some people, if you take it as literal word meaning, it basically stands for extracting value out of text, right? I mean, or extracting something from data. That's essentially the discipline of what data science is. The science around it is probably more, I have a theory that if I offer customers a free ice cream cone every Thursday when temperature's above 85 degrees Fahrenheit, then I'm going to bring in business, right? That's the science part of it. You have the kind of the hypothesis and scientific method. Data mining is, basically the extraction part of ETL. All right, so if you have any more questions, you can reach out to me on Twitter at @tablettier. Pretty sure that we have other ways. One last question. Are languages like C# or Java going to fade by time? I seriously doubt it. In fact, if you look at Hadoop, you look at one of the languages of Hadoop is Java. So I don't think that's going to do that. Yes, thank you, Richard. Shout out to Wintellect Now. Wintellect Now is a pretty awesome thing. I don't say that just because they pay my mortgage. The content there is really awesome. What was the other book I mentioned with O'Reilly? First was Hands-on Machine Learning. Oh, the other one was Data Science Essentials in Python. I don't think it's an O'Reilly book. It's made by Pragmatic Bookshelf. That's a pretty good book. The other one I really liked was, let's see, if you hear a loud crash, that's my stack of books next to my desk. Let's see, Data Science from Scratch. That's an O'Reilly book. That's pretty cool. It's by Joel Gruse. I liked it because it kind of assumes you knew nothing, really. And it kind of explains, how would it kind of takes a programmer through, like, the statistical things and walk through that. I would recommend that one. Difference between AI, ML, and deep learning. So AI is artificial intelligence. That's kind of a catch-all term. ML is also kind of a catch-all term. Deep learning is more specific. Deep learning is basically the idea that you have a neural network. And if you remember from my demo where I did it from playground.tensorflow.org, that neural network, I think, had 2 inner layers. There are neural networks out there that are 300, 400 deep. That's deep learning, right? The idea is that the network that it has to go through is many, many layers deep. So that's basically it. So ML is the process. AI is the generic category, artificial intelligence. ML is machine learning, or the process of a machine learning things on its own. And deep learning is one of the mechanisms to how to achieve that. I have been told I got to wrap this up, and I've also been informed that we will put this webinar up in Dev Center in a day or so, and we'll send out notice to all those who've attended and signed up. Just so if you're wondering, you want to watch this again anytime, and you can. And I want to thank you for being a great audience. And is there anything else I need to do, Kimberly, to wrap this up? Thanks, everyone. Have a great day.